Hello, everyone. Good afternoon. My name is Jeffrey Gillan, and you have tuned in to NextGen Geospatial, the data science workshop series here at the University of Arizona. And let's see, it is April 2nd. Okay, we're flying through the semester. So today we're going to bring you another interesting session, talk about a new cloud computing tool that we haven't talked about yet. Last week, we talked about Google Earth Engine and how kind of a powerful geospatial tool it is in the cloud. Today, we're going to be talking about Microsoft Planetary Computer, which is similar in concept. It's a little bit different. There's some nuanced differences, but kind of similar. It's cloud computing using instead of Google infrastructure, we're using Microsoft Azure infrastructure. It's using their computing and their storage, and there's a very large data catalog, and yeah, it's just a nice little tool. So let me share my screen and we'll get started.
Hi, Jeff.
Hello.
Good morning. Hey, I hope you're well. I have a question. On the schedule, it says that today we're going to cover planet satellite imagery.
What's up? On the schedule, let's see. Which schedule are you looking at, sir?
Oh, the one that was posted very at the very beginning.
Yeah, at the very beginning, things have changed.
Okay.
I've changed them more recently as I've gotten sick and other things have kind of shifted around. Can you see my screen right now?
Yeah.
Okay, so yeah, here's what the schedule is. So today is April 2nd.
Okay.
We're gonna tackle Microsoft Planetary Computer.
Okay.
Next week we're not gonna have anything. I'm actually gonna be gone. The following week, April 16th, we'll talk about containerized pipelines. And so that's bringing in the concept of Docker Compose, Singularity, maybe even talk about Nextflow. So these are all ways to kind of I don't know, daisy chain scripting together into a long pipeline to do interesting and automated analysis. So we'll talk about pipelines on the 16th, and then we'll finish. So the final session on April 23rd, we have a guest speaker from Planet Satellite Imagery Company. He's actually going to come and talk all about the license, the campus license that we have for Planet Satellite Imagery. We started the semester talking about Planet and using their API. So maybe it's appropriate to finish with Planet, and Austin's going to give a kind of a presentation on all the different imagery and products that Planet has that's freely available to U of A personnel. So yeah, it should be interesting.
Jeff, are we still going to cover? Just wondering if we are still going to cover drone image analysis.
No, I decided to kind of shelve that. If you would like to talk about that offline between you and I, that would be fine. I found that kind of a difficult thing to introduce in an hour that would be very meaningful to many people. It becomes very specific very quickly. I guess I thought there would be less of an audience for it, but I sure know a lot about it, so. Ravindra, if you're interested in talking about it, send me an email and we can chat about it all you want.
Okay, I'll do that. Thank you.
Yeah, no problem. Okay, Matina, you're also interested in the drone. Yeah, so what was I going to do with that? I was probably going to talk about Open Drone Map, which is open source program that does structure from motion photogrammetry. That was probably what I was going to do, or I was going to introduce Deep Forest, which is a deep learning Python toolkit to identify tree crowns. So we have colleagues that are specifically using Deep Forest, and I was going to share with it. Yeah, we could. Yeah,
That'll be really good if we can cover that, Jeff.
Okay, yeah,
Hey,
I could still cover that, no problem. It's something I wanted to cover anyway, so yeah, I'll keep you guys updated, but yeah, we could do another session. Um, yeah, specifically on that stuff. If okay. Okay, cool, Matina. Yeah, I'll put that together. Okay, so for today's session, let's go into Microsoft Planetary Computer. And I am posting the content for today. That link I just posted in the chat. Okay, Microsoft Planetary Computer. So yeah, last week we talked about Google Earth Engine. This is a sort of a similar concept, but we had the tech giants fighting it out over who has the best geospatial cloud computing system. I think the trophy still goes to Earth Engine. It's to me that's a really standout, amazing platform. Microsoft Planetary Computer is similar concept, but it's more it uses existing tools. So Earth Engine, what's interesting about it is it has they have all of their own purposely built processing libraries. So they went out and just built all of these JavaScript commands and libraries to specifically do geospatial analysis in Earth Engine. And Earth Engine also has their own integrated development environment, the code editor, which I showed last week. So Planetary Computer does not have these things. Planetary Computer is basically giving you computing access using Microsoft Azure. It also has a large data catalog, which we can browse through here in a minute. And then allows you a few different ways to tap into the computing resources. And then the tools you use are just tools that already exist, i.e. Python and R scripting code. It's basically so you can bring your tools, anything in the R and Python ecosystems you can use. Okay, so that's what Planetary Computer basically is. It is large scale computing. There's a big data catalog already online that you can tap into. You can bring your own data if you want, and you're typically going to use Python in a Jupyter notebook or Jupyter Lab environment. And you can also use R. All right, so let's talk about the data catalog. So like Earth Engine, Microsoft Planetary Computer also has a very large data catalog. And let's look at it. So let me just throw the main link of Planetary Computer in the chat also. So copy link address. Just throw that chat. planetarycomputer.microsoft.com. That is pretty much where you go to get started with everything. And this is where it takes you if you go to that link. And we have something called Explore. And so Explore is a nice kind of web-based visualization tool where we can, let's see, we can just, I think, find data sets of interest and plot them on a map and just kind of see what they look like and decide if that's data we are interested in or not. So let's see here. We have something called biodiversity intactness. Let's check that out. So again, this is just a visualization tool. You wouldn't do any analysis in here. It's simply a place to pull up data that's in the catalog. Let's see if something ends up rendering. Yeah, there we go. I'd have to read into what biodiversity intactness actually means. I don't currently know. Let's see what other kind of data so they've got a lot of satellite imagery collections like Landsat and MODIS and Sentinel. Biomass, that's always of interest. Leaf area index, gross primary productivity, evapotranspiration, a lot of the classic things that we can do from satellite remote sensing. And then it includes a lot of other things like weather and climate. And so a lot of the same data that's in this catalog is probably also in Earth Engine's catalog. Yep, we have NOAA, gridded climate normals, and we have elevation data, of course. Let's click on that. Always like looking at topography. If I click on this, what does that do? I don't know where that actually is on the map. Oh, here it is. It's in Oregon somewhere. Okay, so it's displaying it in something called a hillshade, which is just a nice shadowy thing that looks good to the human eye. Okay, yeah, so that's the data catalog, and the Explorer is just a visualization tool to put it on a map and see what it looks like. If you go to the data catalog tab, that just kind of gives you the list. Then you can browse through and click through and see everything that is in here. Since synthetic aperture radar, snow, MODIS snow daily cover. Okay, that's interesting. So yeah, to find stuff of interest to you, you just kind of browse through the folders and see what you can find. Okay, so yeah, big data catalog that is sitting in Microsoft Azure cloud storage. So it's ready to go. It's hot and ready, and it's really easy to pull it up and use it directly in some kind of scripting language, probably Python. So another thing to know is that all of the Planetary Computer data sets are indexed using spatial temporal asset catalogs, or STAC. A few weeks ago, we did an entire session on STAC. So to refresh you, STAC is just, it's metadata. It's JSON and GeoJSON files that are used as metadata to describe geospatial assets. And so Planetary Computer, they've indexed their entire catalog using the STAC metadata protocol. And it's available at a data API right here. So that's nice. And then we can actually browse through it. So let's browse through it. Let's see, open link in new tab. And so browsing through the STAC catalog or the STAC API, it's the same thing as browsing through the data catalog. It's the same data. There are just multiple ways to find things that of interest to you, but it's all the same data. And so STAC catalogs are nice because it can be programmatically queried. And so when we're using Python or R, we can crawl, directly onto these onto the STAC API, find things of interest to us, and then pull them into our analysis environment, probably in a Jupyter notebook. Okay, yeah, so data catalog, everything's indexed in STAC, which makes it nice to find data programmatically in Python. All right, so then how do we actually get access to using the computing resources? The main way you would do that is logging into something called the hub. And I'll just go to it here. So it's in my, the main menu here of planetarycomputer.microsoft.com, something called the hub. And so what the hub is, it is allowing you to choose some type of virtual machine to start up. And so that means we are tapping into a cloud instance, probably of a Jupyter lab. I think all of this is a Jupyter lab. And it's being launched on Microsoft Azure infrastructure. So this is another example of how we're getting away from our own local computer and tapping into a much bigger computer out there in the sky. And so let's just start something here. So I have a few options. I can start a Jupyter notebook in something called a Pangeo. Pangeo notebook is just like, it has a specific list of libraries or Python packages that are installed. I can launch a Jupyter lab and use R. if you're more of an R person, or I can launch ones that specifically use GPU for machine learning, like PyTorch or TensorFlow. And Ravindra, what's your question, sir?
Um, how did you get to help, Jeff? I tried to do that. It's saying like log in.
Yes, you're going to have to request access. There should be a button. I don't know what it looks like because I already have access, but once you're in the main menu here, is there a hub button for you? Does that exist for you?
Yeah.
Okay, well, I would just kind of follow it through and yeah, I haven't done this in a while, so I don't know what it looks like from your end. But this should be free to use. I'm not
Okay.
sure if you use your university account or if you have to use a personal account. Last week with Earth Engine, you have to use a personal account. Okay, they're reviewing it. Interesting, Ryan. Okay. Yeah, I did this like 2 years ago, so it's been a while since I remember exactly how the getting access works. Okay, they're reviewing it. Well, good to know. Hopefully they review it quickly and get back to you. So yeah, if you're interested in doing this, I would request access now, and then maybe in a week or something they'll have flipped the switch for you, so you can start using it. Okay, so let's say you have access. Um, yeah, you can use basically 4 different flavors, and these are all Jupyter notebooks you're going to be launching. Um, these 2 down here are specifically for machine learning using PyTorch or TensorFlow, and they are going to be hooked up to a T4 GPU. So these other ones are probably not using GPU. They're probably just using CPU. So let's just start a regular one here, a CPU Python environment. And this should just take like a moment.
I just requested SS for Hub. Yeah.
Okay,
So
great.
thank you.
Yeah, great. Yeah, hopefully they get back to you soon. Okay, so what you're seeing on my screen then is Jupyter Lab. A Jupyter Lab and a Jupyter Notebook are kind of the same thing. The Jupyter Lab part is just a little more fancy, a few more bells and whistles, but it's essentially the same thing. Let's see here. Okay, so when you first launch it, yeah, before we get into this tutorial, let me see, was there anything else I needed to mention in the course content? Code examples, scaling your analysis. Okay, well, we're going to do all that. So when you launch a cloud instance here of Jupyter Lab, first thing that you land on is a README, which is nice. And so they're like, read this first so you can have an idea of what's going on here. So in this README, it gives you several, we got some in the chat. Art, yep. Okay, yeah, so the README here, that's where you land. And what's nice is they give you some quick starts. So they have like many different notebooks, and each notebook has like a little mini tutorial on how to do things. So they have a bunch of quick starts on like, how do you read data from the Stack API? So, because that's how you bring data into your environment here. How do you do it with Python? How do you do it with R? Some other things. How do you read tabular and ZAR data? We are going to do dask here in a little bit. That's pretty cool. Then they list all the data sets. So all the data that we showed in the catalog and the stat catalog, it's also just here. It's also listed here. So what if I click on this? What does that do? Okay, it gives you an example. So that's fantastic. So it looks like for every single data product, it has a little Jupyter notebook that shows you how to bring that data directly into your analysis environment. And then looks like they have a few simple things you could do with it. So that's fantastic. They're giving you all kinds of examples, basically, of how to get started. Um, Most of it's probably Python. I don't know if they have examples in R or not. Let's see. So all of these data products, let's see, it's probably all Python. Yeah, Python. Then they have a bunch of tutorials, which is great. Classification, how to make cloudless mosaics, just a whole bunch of kind of geospatial analysis things. They have them all listed here. So if we click on one, surface analysis. Okay, so it's going to take you through a tutorial of how to do hill shades and slope and curvature and aspect, all using a digital elevation model. And so all of these examples and tutorials are all Python based, it seems.
It's a Jupyter notebook,
This is a Jupyter notebook.
not RStudio.
Well, yeah, but you can get an R kernel. So you can do R in Jupyter. I just don't really see people do that too much.
But R is commercial. RStudio is commercial.
Okay.
Microsoft is commercial, so Microsoft is using just Python, which is open source.
Okay, yeah. And outside of the niche academic disciplines, no one's using R. People that use R are mostly like people in ecology, gosh, I don't know, and health sciences are people using R. It's really pretty much limited to academia for the most part. So Python is a much broader language, broader base. A lot more people are using it. So don't be afraid to branch out. And if you're an R person, getting going with Python is not really all that different. Like the syntax is a little different, but the concepts and what you're doing is all pretty similar. Okay, so this README is great. It gives you all kinds of examples of how to do things in Python. Yeah, it's been immensely useful for me to kind of just get started with it. Okay, so let's do an example. Scale with dask. Here, let me just clean this up here. Okay, I'm going to go on this quick start called Scale with dask. All right, so dask. So with Microsoft Planetary Computer, you start up a virtual machine, right? But it's not that big of a virtual machine. It's 4 cores, 32 gigs of memory. It'll work for projects, but if you are doing something bigger, you're doing really like global scale analysis or even, continental scale, or, you're doing something big, you're going to need more firepower. And that's what dask allows you to do. And so just with a few lines of code, you can scale your analysis. So instead of using just one computing node, you can use many. And that to me is really kind of the selling point of using Microsoft Planetary Computer. The fact that you can scale it. And so if you're doing some big analysis that would take, months on your own local machine, you could do it here in Planetary Computer, and you could request to get much more computing nodes. And in theory, you could do it a whole lot faster. So that's really the selling point to me with Planetary Computer. And it's not that hard to do. So we're gonna do it. So I got some of the chat. Cities and counties. What was that in regards to, Ryan? Size. Okay. Yeah, size of computing. Yep. So with using dask, we can say, hey, I would like 4 worker nodes to work on this thing. Or you can do auto scaling, which will, you do your analysis and it will give you the computing resources you need based on how much analysis you're doing. So that's kind of cool. And so we're going to see an example of this auto scaling. Okay, so let's just do it. Let's just start running it. So I'm here in my Jupyter notebook. This notebook is an example of how to scale with dask using Microsoft Planetary Computer. And I'm just going to start running the blocks of code. And so this block of code is going to import the Python library dask gateway. And then it's going to say, I would like 4 computing nodes or 4 worker nodes to do, to start to do my analysis. So let's just hit play here. Okay, it is thinking. Okay, looks like it was successful. And it gave me this URL. And so this is like a dashboard URL. So I'm going to open it. I'll just click on it. Okay, so it's kind of like a view of my 4 nodes. So 1, 2, 3, 4. So I have 4 workers. I don't quite understand all the visualization of this dashboard yet. But we can see it in action when we start to actually run things. Okay, yep, so I open the dashboard. Do hotkeys, control plus work with the code. I don't know. Let's see. So if I go here and I hit control plus, is that what you're saying? I don't know.
Increase the size.
That's it.
Command.
So instead of hitting the play button, you wanted to just like do a key command, is that right?
Yeah, like control enter or something.
Yeah, okay. Is that what it normally is? Shift?
Enter.
Nope, it's not
Inside.
that.
Okay, no worries.
Oh, yep, yeah, it's just shift enter, shift return. Yep. Yeah, every kind of flavor of Jupyter notebooks seems like they're all a little bit different in terms of like what commands do what. So it looks like we ran that block of code again. No big deal. Yes, Ravindra.
So Jeff, I saw you're able to run your code, but when I clicked on the scale with dask, open as a new tab, and it's not showing me like I can click it. You're saying launch in hub, which I don't have the access to. So what can I do with this?
Nothing, nothing yet. So you don't have access to hub yet, right? You're not actually connected to a
Yeah.
virtual machine.
Yeah.
So then,
Okay.
yeah, it's not going to be a whole lot of help to you. You need to be on Azure infrastructure, on your own virtual machine or something for that to be useful.
Okay. Thank you.
Yep. Okay, I lost it. There it is. Okay, here's my dashboard again. All right, let's just keep rolling here. So we open up the dashboard. Yep, that's kind of like a monitor to look at our nodes and see what they're doing, how much they're processing. And they give a little screenshot of what things might look like, but we're actually going to run it. So what I showed you is a way to specify the number of nodes. And let's just follow the tutorial here. They want us to close that, which is fine. And we're going to open it in a different way. So I think this is probably dead, this monitor. Since I closed that cluster, this is probably dead. Yeah, it's dead. Good. All right, but we're going to open it in a different way. So instead of saying we would like 4 nodes, we just we do adaptive. So we say, hey, we're going to do this thing, but make it adaptive. Give us the resources if we need it, which is kind of interesting. All right, so I'm going to hit play here. Hit run, and it is going to, again, I'm asking for the clustering abilities. Okay, cool. I've got here's my dashboard link. Let's see what it shows. It shows nothing because we don't know what our resources are yet, I think is the deal. Okay. All right, but we have our cluster ready. It's standing by, waiting for instructions. And so in the tutorial, they have us using meteorology data from DayMet. Okay, it's minimum daily temperature averaged over Hawaii. And so we're going to do just a little analysis here. So we'll start with importing the libraries we need. So we need PyStat client because that's how we're going to crawl through the stat catalog and find the data of interest to us. And then, of course, we're using Planetary Computer, so that is the library we need. And then we're using an analysis library called Xarray. That's used for raster data or multi-dimensional array data. All right, this is account name and container name. I'm not really sure what the meaning of this is exactly. Why that is there. Any idea, Carlos? Account name, container name.
You need a username to run the process.
I think it works just by leaving it as is. This next line of code is crawling the stat catalog. So that's what that is. So we're gonna use the stat client to crawl the stat catalog. The stat catalog for Planetary Computer is at this address. So that's the starting point for that API. And I guess the sign in here, this should work without having to do anything since we're already signed in into Planetary Computer. Okay, and then the asset, like the actual data that we're going to get, is something we predetermined, and that is this DayMet daily temperature averaged all of Hawaii. And I don't know what the time frame is for that, so we'll see. Okay, so yeah, we're going to pull out some data. Let's say we're going to pull up these a whole bunch of raster data from DayMet, and then I think we're going to pull out the data, get averages, and then plot them in a table. That's like in a graph. I think that's what this block of code does. And this is just a kind of demonstration of the scaling with dask.
Be
So,
consistent with like syntax. How would I know what to look for? For instance, like the DayMet in the parentheses. Is that verbiage that I would find in the stack or?
yes, yeah, exactly. Yeah, you would find it in the stat catalog. Do I have that still up? Yeah, in here, I think, is where you would actually find like, yeah, in the parentheses, like what is it actually called?
Right, making that
I
call.
think you could find it in here, yes. Okay, so let's just run this code block here. Okay, what this code did, okay, so it didn't do the plotting yet. It just pulled the data, the meteorology data. Now it's just showing me what that data, like details about the data. Okay, great. I now know all about the data. It's this one where it actually is like, let's do a time series and pull data from, I guess it's going to do it over 40-year time span. So it seems like it's kind of compute intensive. So let's hit run on that.
Is it possible to modify the projections? I noticed that they had like Lambert conformal or something on there. Yeah, and
That is that's the native projection. Yeah, I'm sure you can, in terms of if you want to output it, you can change projections kind of many different places along the workflow. Maybe since it's in Lambert conformal conic, maybe you just do your analysis in that, and then if you want to then output it to something
The script line.
like a UTM or, you know, something more common, you can maybe do that after the fact. I'm not sure. I'm not sure what the library is, but for sure there are Python libraries. Probably like raster IO might be the Python library to do that. Okay, so it made our graph. Let's do that again, only let's watch the monitor. And so if I hit run here, and then I look at it, and so this is dynamic scaling with dask. So is it just using 2 nodes? Oh, now it's using like 6. And it's over. Okay. That's interesting. Let's try running it again. Hit run. Look at our monitor. I just want to see what it's doing.
Let's do 6 so it can get done faster.
Yeah. Okay. Yeah, so I'd have to do some benchmarking or something to see, like, you know, how long would that have taken if I just used one of the computing nodes, as opposed to, you know, this auto scaling where it looked like it used like 5 or 6 at the same time. I don't know. I haven't used this enough to know what kind of efficiencies, but for sure it went a lot faster. And I think the same thing is happening in Google Earth Engine, only you don't see it. It's behind the curtain. And in Earth Engine, you just hit run and it processes things very fast. So my guess is it's also doing auto scaling in terms of how many resources it is using to do the processing. Here in Planetary Computer, you specify. You can say, give me 10 nodes, or you can just say, do this auto scaling, and it'll just algorithmically figure out how many resources to throw at it. So yeah, that's kind of interesting. And they always want you to close things. So it's always good with cloud computing. It's like once you turn something on, use it, please turn it off. And so we'll hit cluster close. Okay, and down here, it looks like you can get even more customization in terms of how many worker cores, how much worker memory, use GPU or not. So it looks like there's a lot of customization you can do in terms of your computing resources. And I probably have to dig into the documentation to know like what the limits are, you know, with a free educational or academic account. This is probably not unlimited. I'm sure there's some kind of bar, you know, ceiling or something when it comes to my processing resources I can use from Microsoft. I'm not sure what it is, but yeah, this is kind of interesting that you can really get specific with your processing resources. So if I click some of this stuff, all right, what is this going to do? Cluster options. Okay. We're going to say worker memory, 16 gigabytes. Okay, I don't think there's anything to see here other than that you can specify that I'd like the worker memory to be 16. Let me see if I can see that. I need to print out my my dashboard. Okay, so yep, I'm in the process of getting resources. Looks like I was given some. And I have 2 worker nodes. And I think we specified 16 gigabytes of memory. I don't know. Maybe somewhere in here that's expressed in some way. I don't know this monitor very well, but Okay, so that is Planetary Computer. Yeah, I haven't used it for any like real project or production or anything, but I played around with it for a couple years, and it is a very interesting resource. You know, you can get free access to it. It gives you a cloud instance, and with the dask, you can scale your analysis to much larger. I'm not sure what the limitation is exactly. I've never hit the limitation, but everything you do here is mostly in Python, and they've got a whole lot of great um, tutorials and such, and examples of how to get data in, how to do some analysis, how to get data out. Just kind of the basics of how to get rolling with it. So yeah, it's very useful. Does anybody have any questions? Elizabeth.
Yes, hey Jeff.
Hey.
So the main difference is, so when would you prefer to use Google Earth Engine, and when would you use Microsoft Planetary Computer when doing some of this visualization and analysis, and why? Why would you prefer the one over the other?
Oh, it probably comes to user preference.
Hmm. Okay.
Yeah, so Earth Engine, most of that is a JavaScript interface. You can do it in Python, for
Okay.
sure.
Okay.
But the main editor is in JavaScript, so that could be part of your decision, is what language are you more comfortable in. It could be, is the data that you're interested in working with, where is it? Is it on Planetary Computer's data catalog, or is it in Earth Engine's catalog? And then it just becomes kind of user preference for what you're comfortable. They both can do pretty similar things. There is a much larger community of people using Earth Engine. Planetary Computer seems like a more recent kind of upstart. But Earth Engine has a very large and growing user database. A lot of people have been using it for many years, and so it's just probably a more mature platform. You can probably find other more colleagues that are using Earth Engine. So yeah, that could be some of the reasons to choose one or the other.
Okay. Yeah, thanks, Jeff.
You're welcome.
The Jupyter notebooks from Microsoft Planetary Computer
Mhm.
into Google Colab, but then you need.
Yeah, so Carlos was saying that you could probably use the same Jupyter notebooks, the same Python code for either one of the platforms. Because yeah, in theory you could. For Earth Engine, you don't have to do it in JavaScript. You can also use the processing capabilities based from a Google Colab Jupyter notebook. And so you could develop a notebook here in Planetary Computer and then just port it over into Google Colab and then run it in Earth Engine. So it seems like there's a lot of overlap between like the two systems, and like I said before, it's like the two tech giants are battling it out over cloud computing supremacy. And so far that's just kind of good for for the user. The geospatial analyst has just all of this processing capabilities and data at their fingertips. And if you were in kind of academic, educational, or I don't even know about government, but most of it is free or low cost.
Okay, well, that's good to know. So I can run, if I develop a Python-based Jupyter notebook, I can port that over to Google Earth Engine. Okay.
Yeah, I think so. Through Google Colab. Google
Okay.
Colab.
Okay.
Yep. But yeah, in Google Colab, you can tap into Earth Engine, and there's plenty of tutorials and stuff on how to do that. I think I actually in my Earth Engine material from last week, I did give a link for a whole bunch of Jupyter notebooks that are specifically for Earth Engine.
Thanks, Jeff.
Yep. Okay, one final thing to do here, when I'm done using this virtual machine here, I need to shut it down. So I can go to my file here, hub control panel, and I can say stop my server. That's always good etiquette in cloud computing terms. You don't want things running if you're not using them. I have no idea if there's an allocation that I am burning through, being unaware of it. So you're done with the computer, please shut it down. And so now it's available again for me to start a new server and choose what I want to get rolling again. So kind of a take home from a lot of this semester in this workshop series is there is ample compute out there that you can just tap into. We're kind of in a world where you're doing geospatial analysis. You probably don't need to go out and buy a really fancy computer. There are really fancy computers out there that you can just use in the cloud. So yeah, it makes things a little bit easier for us all. Okay, any other questions? Okay, I'll stop the share here. Well, thank you all for attending. Like I mentioned earlier today, is that next week we're not going to have anything. I will not be here. But the following week, we will be doing containerized pipelines. The week after that, we will have a guest speaker from Planet Satellite Imagery. And then by request, probably the following week, we can do something on drones using Open Drone Map and maybe Deep Forest and how to kind of get rolling with that stuff. So thank you very much, and we'll see you in 2 weeks.